Activation functions. Activation functions play a crucial role in neural networks by introducing non-linearity, allowing neural networks to learn complex patterns and relationships in data. They are applied to the output of each neuron in a neural network, transforming the input signal into the output signal that is passed to the next layer. Let's dig deeper into activation functions. The first one that we'll look at is linear activation function. The linear activation function simply passes the input unchanged, making it suitable for regression tasks where the output can be any real number. However, it's rarely used in hidden layers of neural networks due to its limited representational power. Mathematically, you'll write it as fx equal to x, or function of x is x. TensorFlow usage is output equal to tf.keras.activations.linear and pass the input there. Next one is the sigmoid activation function. The sigmoid activation function squashes the input values between 0 and 1, which is useful for binary classification tasks where the output represents possibilities. Mathematically, you write it as function of x equal to 1 divided by 1 plus e raised to minus x. TensorFlow usage is output equal to tf.keras.activations.sigmoid and pass the input there. Hyperbolic tangent or tanh activation function. The hyperbolic tangent tanh activation function squashes the input values between -1 and 1, making it suitable for hidden layers of neural networks where the input can be both positive and negative. Mathematically is represented as fx equal to e raised to x minus e raised to minus x divided by ex plus e raised to minus x. The TensorFlow usage is output equal to tf.keras.activation.tanh and pass the input to it. The Rectified Linear Unit or ReLU activation function. The Rectified Linear Unit activation function introduces non-linearity by outputting the input value if it's positive and 0 otherwise. ReLU is widely used in hidden layers of neural networks due to its simplicity and effectiveness in training deep networks. Mathematically, it's represented as f of x or function of x equal to max of 0, x. TensorFlow usage is output equal to tf.keras.activation.relu and pass the input to it. Next one is Leaky ReLU activation function. The Leaky ReLU activation function addresses the dying ReLU problem by allowing a small positive gradient when the input is negative. It helps prevent the issues of neurons becoming inactive during training. Mathematically is represented as function of x equal to x comma alpha minus x if x is greater than 0, otherwise it's alpha minus x. TensorFlow usage is output equal to tf.keras.layers.leaky ReLU alpha is 0.2 and pass the input to it. Next is Softmax activation function. The Softmax activation function is commonly used in the output layer of neural networks for multi-class classification tasks. It squashes the input value into a probability distribution over multiple classes, ensuring that the output sums to 1. Mathematically is represented as function of xi equal to e raised to xi divided by summation of e raised to xj. TensorFlow usage is output equal to tf.keras.activation.softmax and pass the input to it. So activation functions introduce non-linearity into neural networks, allowing them to learn complex patterns and relationships in data. By understanding the characteristics and mathematical properties of different activation functions, you can choose the most appropriate one for your neural network architecture and task. Experiment with different activation functions and monitor the impact on model performance during your training and evaluation.